Hey, so we've been discussing how to graph equations, especially linear equations, using slope-intercept form. And right now we're going to move a little bit further and we're going to talk about solving systems of equations by graphing. And what this is going to do is somewhat give us a purpose for why do we graph equations. So we want to dive into this. We want to explain it and just kind of take a preliminary look at systems of equations. So first of all, what is a system? Systems of equations are two or more equations that contain the same variables. When we say the same variables, it doesn't mean it's only x. It means we're going to have equations that have x and y. And especially now, because we're talking about graphing, we're probably going to make sure that they're in slope-intercept form. So they should be y equals, all right, some slope x plus some sort of y-intercept, y equals mx plus b. And we want to solve the system of equations to determine where these two equations would meet. And the answer is actually going to be an ordered pair, because the whole purpose of this is to find out where they meet. So if we're graphing them, where they meet would be an intersecting point. So we need to make sure that our answer is going to be an ordered pair, x and y. So how do we solve them? Well, we want to graph. And when we graph an equation, we're going to follow the same steps that we followed when we were in our last chapter. So the first step is to make sure that we have the same variables. X and Y are typical. Can we have other variables? Absolutely. Okay. But if we are going to be graphing them, we should make sure that one value is going to be X and one value is going to be Y, since we're going to use an X and Y intercept. As we get deeper into this, we'll introduce other variables and we'll be able to talk about different ways to solve them. But for right now, we want to graph them, so we need to have an x and a y. The next step is to make sure that we solve for y. So we want to have them into slope-intercept form, which, if you remember, is the y equals mx plus b format that we discussed in the earlier chapters. Step 3 is to graph. Now remember, when we're graphing these, because they're in slope-intercept form, we already know the y-intercept. That's the whole purpose of the intercept part of that form. So we find that b value, go to the y-axis, and plot our point. Then find the slope and move according to the slope. So for example, if the slope was going to be 2/3, that means up 2, right 3. So we would plot our point, move up 2 spaces, right 3 spaces, plot another point. And if we can, let's plot a third point on that graph. But we need at least 2 points. Draw our line and graph it. Okay? Now we do that for both equations. Then once we have graphed both equations, step 4 is to identify and label the point where those two lines intersect. That is going to be the ordered pair xy that would be the solution to our system. So let's take a look at an example. In this example, we want to solve this system by graphing. So we have our two equations, y equals 4x minus 3 and y equals negative 2x plus 3. So one we're going to graph in red, the other graph in blue, just to kind of separate them and help our eyes a little bit. So if we start, we want to find the y-intercept for the first equation, which is at negative 3. The slope is 4, which means 4 over 1, which also means up 4, right 1. So when we move up 4, right 1, we find our second point. Once we do that, we can go ahead and graph the line. We need at least 2 points to be able to graph the line. So next, we want to find the intercept for y equals negative 2x plus 3. So we go to plus 3 on the y-axis because it's plus 3. The slope is negative 2, which means negative 2 over 1, which means down 2, right 1. And when we plot that point, already I realize that's on the line. So I'm going to keep that in the back of my mind. I'm going to draw my line anyway, and I find that they intersect right here. Well, this point that they intersect at is 1, 1. So that means that after graphing, the solution to this system would be 1, 1. All right, so here's another example. We have y equals x plus 2 and y equals negative 2x minus 4. So we graph the first at plus 2, up 1 over 1 because the slope in front of x, even though it's not written, is assumed to be a 1. We draw our line. Plot our next point at -4. Now, we couldn't go down to right 1 because our slope's -2. So if I can't go down to right 1, I just do the exact opposite. I do up to left 1. Graph my point. We'll notice that they intersect at -2, 0. So our solution would be -2, 0. Now, we use systems to solve real-world problems as well. So we can use them in word problems. And when we do that, we want to make sure that as we write the equations, our variables end up being the same. All right. So here's just an example of how that could happen. And what it does is allows us to compare different quantities over the course of different events. Okay. So in this example, it's a doctor's office. They're talking about new patients and existing patients. And then they further compare that by saying that the new patients is 22 more than the existing patients. So we write out our equations, and when we graph those together, we find an intersecting point at 2244. But since we said that x was existing, that means that there are 22 existing patients, and y is the new patients of 44. So we were able to use graphing to be able to solve this actual problem and figure out how many patients we were dealing with. Now, not every set of equations will be given in slope-intercept form. I think you guys saw that one coming. When we talked about graphing in slope-intercept form, we spent a lot of time solving for y. So that's going to come back, especially in this section, because we want to be able to put them into slope-intercept form, but we understand that they're not always given that way. So here's an example. We're given the first one, y equals 3x minus 3. This is in slope-intercept form because it's y equals the slope of 3x, and then the minus 3 tells me the y-intercept. The second equation, though, is not. All right, this is in more of a standard form. All right, so what we have to do is we have to solve this for y. So here's my work. All right, we subtracted x from both sides. Then we got 2y equals -x plus 8. We divided by 2, and remember to divide by 2 on all parts on the right-hand side. So y equals -1/2 x plus 4. So I graphed this, all right? Plotted my 4, went down 1, because it's -1/2, down 1, right 2, down 1, right 2, and I graphed my line. And then I took the other equation, which was already in slope-intercept form, and it started at -3. And then we graphed according to the slope of 3, which is up 3 over 1, up 3 over 1. And we find out that they intersect right here at 2, 3. All right. So our solution is 2, 3. But nothing really changed as far as the graphing and finding the solution. The only thing was setting up the problem. And we have to realize that it needs to be in slope-intercept form in order to graph it. So bottom line, the big important thing is that when we solve systems of equations by graphing, we want to make sure that we're finding the point where they intersect. So our solution, again, I'm telling you this because I don't want you to get this wrong. Our solution is going to be a point. We have to write it as an ordered pair where we write it as parenthesis, the x value, comma, y value, end parenthesis. Now, one little thing. Something I want you to consider. What if the two lines are parallel and they never intersect? What is the answer to their system of equations? So when we're doing this, you have to realize that sometimes we deal with values that are parallel. We've seen parallel lines, and by definition, a parallel line is not going to touch or intersect. So here's our demonstration. It has no solution. What we're saying is that these are going to be completely parallel. They're never going to intersect. And if they don't intersect, then they don't meet. And if they don't meet, we can't find the intersecting point, which is the answer to the system. So anytime you graph two lines and you find out that they're parallel, we're going to say that there is no solution. So again, we're solving systems of equations. It's really just more graphing practice for you. Make sure that they're in slope-intercept form. Make sure when you're graphing, you graph the y-intercept first, then move according to the slope. Make sure that you're paying attention to the negatives, and make sure that you write your answer in the form of an ordered pair.